All right, backside is just more practice with solving for x with the different types of graphs that we're dealing on the front side. Here, we just don't have to do the graphs. So it's just doing all your inverse operations and solving for x and checking your solutions. So on the first one here, x minus 3 quantity squared minus 9 equals negative 5. So inverse operation says take care of all the addition subtraction stuff first that's outside of parentheses. So when I do that, I have x plus 3 quantity squared, cross out, equals 4. Next, we want to get rid of the square. So to undo the square, we square root. Don't forget plus or minus here. So when the square and square root cross out, I have x plus 3 equals plus or minus the square root of 4 is 2. So this means we're going to more than likely have two solutions. So now I'm going to subtract 3 from both sides. So x equals negative 3 plus or minus 2. So x equals negative 3 plus 2, negative 1. Negative 3 minus 2 is negative 5. Now one of the things I should do is check. Well, if I go negative 1 plus 3 and square it, that's going to give me 2. 2 squared is 4. 4 minus 9 is negative 5. So negative 1 checks off. Check negative 5. So negative 5 plus 3 quantity squared minus 9. Well, negative 5 plus 3 is negative 2. Negative 2 squared is also 4. 4 minus 9 is negative 5. Check. It's always good to check your solutions because sometimes you'll get an answer that doesn't work. All right, number 5. Same process, get rid of all the adding and subtracting. Well, we're adding 4 to the square root piece. So I'm going to subtract the 4 and isolate the square root. So I have the square root of x minus 2 equals 3. So to undo the square root, I square both sides. So the square and square root cancel out. I have x minus 2 equals 9. Add 2 to both sides. X equals 11. I do a quick check. 4 plus the square root of 11 minus 2. Well, 11 minus 2 is 9. Square root of 9 is 3. 4 plus 3 is 7. That's what it should equal. And it checks off. Number 6, negative 3 absolute value of x plus 5 equals negative 7. Okay? So the first thing I'm going to do is subtract 5 from both sides. So negative 3 absolute value of x equals negative 12. And I'm going to divide both sides by negative 3. So absolute value of x equals 4. Well, distance from 0 on a number line, x, that's what it represents, is 4 units away. So x could equal 4, or it could equal negative 4. If I check both of these, if I plug in 4 here, the absolute value of 4 is 4. 4 times negative 3 is negative 12. Negative 12 plus 5 does equal negative 7. If I check negative 4, the absolute value of negative 4, so if I go 3, absolute value negative 4 plus 5, does that equal 7? Absolute value of negative 4 is 4. It's 4 units away. So that becomes negative 12 plus 5. Does that equal negative 7? Sorry, that should have been negative 7. And sure it does. Checks off. So both answers work. Number 7. X squared plus 7 equals 3. So I'm going to subtract 7. Whoops, I meant to switch colors just so that it's a little bit easier to follow. So, subtract 7 from both sides. And I do that, I get x squared equals negative 4. Well, if I take the square root plus or minus, I'll get x equals, well, can you take the square root of a negative number? Right now, you can't. So this would be no solution. Later on in this course, we'll talk about how we can get complex solutions. So right now, no solution. Can't take the square root of a negative number. Number 8. Looking at number 8 here, it says 3 minus 2, absolute value of x plus 4 equals 3. All right, so subtract 3 from both sides. So negative 2 absolute value x plus 4 is equal to 0. Divide by negative 2. You still get absolute value of x plus 4 equals 0. Well, the absolute value can be equal to 0. Distance can be 0 units long. You just haven't traveled anywhere. So on this one, we remove the absolute value, set it equal to 0, set it equal to negative 0. Well, that's just 0. So you're only going to have one solution here, and x equals negative 4. Now, if I wanted to check it, I would just go, well, what's 3 minus 2 absolute value of 4 minus 4? Does that equal 3? Well, 4 minus 4 is 0. Absolute value is 0, 0. So 3 minus 0, does that equal 3? Sure enough, it does. It checks. Whoops, I'm sorry, this shouldn't have been 4 minus 4. It should have been negative 4 plus 4, which is still 0. My fault on that with the checking. Put it in the wrong spot. All right, number 9. Square root of x minus 9 equals negative 5. So both sides add 9. So the square root of x equals 4. To undo a square root, we square both sides. So I get x equals 16. I'm going to check it. Square root of 16 minus 9, does that equal negative 5? Square root of 16 is 4. 4 minus 9 is sure enough negative 5. Checks off. Number 10. First thing I want to do with this absolute value is divide both sides by negative 2. So the distance of x minus 8 is 5 units away from 0 on the number line. So what that means is x minus 8 is either located at the number 5, or x minus 8 must be at negative 5, because negative 5 is 5 units away from 0. So solve each of these, and you have for x. So I add 8 to both sides, so x equals 13. Add 8 to both sides, x equals 3. So in this one here, we have 2 solutions. Now you can check both of them. If I check the 13, 13 minus 8 is 5. 5 is 5 units away. 5 times negative 2 is negative 10. This one checks off. When I check the 3 minus 8 is negative 5. Negative 5 is 5 units away. 5 times negative 2 is negative 10. They both check off. Number 11 is tricky for some because they'll just start saying, oh, I just changed the sign. But again, absolute value means distance from 0. So distance from 0, notice how it says negative 9. Can't have negative distance. Again, can't have negative distance. Therefore, this has no solutions. All right, the last 2 problems that we have. I'm going to move this up a little bit. Oops, it might jump too far. Figured that was going to happen. Got to be a little more patient. So, same process, inverse operations. So to undo subtraction, add 4 to both sides. So 5 square root of x equals 5. Well, to undo multiplication, divide. So the square root of x equals 1. To undo a square root, square both sides. So x equals 1. I can check that if I want to see to make sure if it's right. Does 5 times the square root of 1 minus 4 equal 1? Well, the square root of 1 is 1, so does 5 minus 4 equal 1? Absolutely. So that answer works out beautifully. Number 13, same process, just trying to get x by itself. So subtract 5 from both sides. So x minus 6 quantity squared equals 7. Next part is I want to square root both sides. Square root, square root. So x minus 6 equals, don't forget the plus minus. So plus minus the square root of 7. So now I want to add 6 to both sides. So I get x equals 6 plus the square root of 7 and 6 minus the square root of 7. Or you could write it just by combining the answers together with the plus minus symbol. However, this one's a little more interesting when checking, because when you check this one, just to show you, like for the first one, I'd go 6 plus the square root of 7, so I got to replace the x with it, minus 6 quantity squared plus 5 equals 12. Well, here's what you're going to see what happens. When I combine like terms here, the 6's cross out. The square root of 7 being squared is just 7. 7 plus 5 is 12. 12 equals 12, checks off. If I check that last one, same process, I'm going 6 minus the square root of 7 minus 6, quantity squared, plus 5 equals 12. The 6's again cross each other out. Well, a negative being squared is positive, so this still ends up being positive 7 plus 5 equals 12. That also checks out. So both those answers work. All right, that ends your video here.